In this project, we will complete our online weather station. We will combine the Arduino Wi-Fi shield and our LCD in one circuit. Using the Weather Underground API, we will retrieve weather information online and then display this information on our LCD screen. This project brings together all the components that we have learned so far and shows how you can incorporate wireless technologies in your Arduino projects. Let's finish up this project. Here are the objectives for this lesson. By successfully completing this project, we will have mastered the following items. You will learn how to integrate the Wi-Fi shield and an LCD to create an online weather station. You will also understand how the Weather Underground API can be used to retrieve weather information for your city and periodically update this information on the LCD. If you are ready to begin, let's get this project started. Here are the parts we will need: an Arduino Uno, a USB cable, a breadboard, an Arduino Wi-Fi shield, a standard 1602 LCD, a pin header strip with 16 male pins where appropriate, a 10 kilo ohm potentiometer, a 220 ohm resistor, and connecting wires. Let's take a look at the circuit diagram. To make things a little simpler, I have included this cheat sheet on the right-hand side of the circuit diagram. So from our pin 1 on our LCD, we go to ground, the ground rail on the breadboard. Pin 2 is connected to the 5-volt rail. Pin 3, which is our contrast pin, goes to the center of our potentiometer, that middle pin. The other ends of the potentiometer, one pin is grounded, and the other pin goes to 5 volts. Pin 4 on the LCD goes to pin 2 on the Arduino. Pin 5 is grounded. Pin 6 is connected to pin 3 on the Arduino. Pins 7, 8, 9, and 10, as you remember, are unconnected. Pins 11 is connected to pin 4 on the Arduino. Pin 12 is connected to pin 5. Pin 13 is connected to pin 8 on the Arduino. Pin 14 is connected to pin 9. And pin 15 is connected via a 220 ohm resistor to 5 volts. Finally, pin 16 on the LCD is grounded. Don't forget, we have to connect the ground pin on the Arduino to the ground rail on the breadboard, and the 5-volt pin on the Arduino is connected to the 5-volt rail on the breadboard. That completes our wiring. Let us complete the wiring for our online weather station. So initially, I'll connect. Remember, we have our Wi-Fi shield that's connected to our Arduino, so don't forget that. I'll connect the ground connection on the Wi-Fi shield to the ground rail on our breadboard. Then I'll do the 5 volts to 5 volt rail on the breadboard. Okay, so first, pin 1 is connected to ground. Our pin 2 goes to 5 volts. Pin 3 goes to our potentiometer. So I'll connect the potentiometer here on our circuit. So here's our pin 3, goes to the middle pin on our potentiometer. The other ends of our potentiometer, one pin goes to ground. And the other pin goes to 5 volts. Next up, pin 4 goes to pin 2 on your Arduino. Pin 5 is grounded. Pin 6 goes to pin 3 on the Arduino. Pins 7, 8, 9, and 10 are unconnected. Pin 11 goes to pin 4 on the Arduino. Pin 12 goes to pin 5. Pin 13 goes to pin 8. Pin 14 goes to pin 9. Then we have pin 15 has that 220 ohm resistor. Alright, so I'll connect that. And the other end of that resistor goes to the 5-volt rail. And finally, pin 16 is grounded. Okay, that completes the wiring for our online weather station. Okay, let's go ahead and upload the code for our online weather station. Alright, so while that's uploading, I will open up the serial monitor. Okay, so initially when we are attempting to connect to the network, you'll see that retrieving weather message showing up. So that's gonna just stay on there while we connect to our network and retrieve the information. So we'll wait a bit. Remember, we have that 10-second delay in there. So now we have connected to the network, and pretty shortly we should be attempting to retrieve the information from Weather Underground. Alright, so there you have it. It retrieved the weather. It was overcast, humidity is 70%, and the temperature, you'll see, is 24.5 degrees. Yes, it's pretty cold, Fahrenheit. There you have it. We're able to retrieve the information, and again, this is for Bloomington, Illinois, weather information here, and you can change this, of course, appropriately for your particular state and city, or if you're internationally, you can put in your country and city, and it should retrieve the information. So there you have it. We're using our Wi-Fi shield to connect wirelessly to the internet to call the Weather Underground API to retrieve weather information. We're then extracting that and displaying it on our LCD to create an online weather station. You can leave this powered up. Currently the code is set to only query the API once every 10 minutes, so we will not go beyond the quota that we're allotted for free usage. So we should be good to go. So every 10 minutes this will make another call and it will update to reflect updated information. Let's dive into the code for our online weather station. So initially at the top we include the Wi-Fi library as we've seen before and the Liquid Crystal library. So those are the two libraries we need for our program. Then we have our network and our password. So you would put in the appropriate network you want to connect to, your home network or hotspot or what have you, and the password to connect to that network. A lot of this is the initial, some of the boilerplate code we have seen before. There are some variables that we use here for keeping track of, indicator for the temperature that's found and the weather and the humidity and so forth. So these are just some global variables that we're using to keep track of things in our program. And here we have some arrays around the weather string, and humidity that allows us to store that information that we retrieve from the weather service. Next, we'll plug in our API key and also put in the state and city for folks that are in the US. Otherwise, for international folks, you would put in the name of your country or city. Remember, if you're international, you have to comment out these lines of code and uncomment these, or vice versa. If you are in the US, make sure that these are commented out and you have these uncommented. Next, we set up the liquid crystal, the LCD object, and we specify the pins that we connected to. There is a small wiring change from our initial LCD project, and the reason is because there are some pins that we cannot use on the Wi-Fi Shield because they have, they're used for SPI communication. So that's why we have to be careful about the pins that we use, and they're a little different from our original program. In our setup, here's where we show that retrieving weather message. Initially that shows up while we connect to our network, so that's a little piece of new code in there. What follows is the same code to connect to our network. We've seen this before. And essentially in our loop function, once we have connected to the network, we begin reading in the response that came back to us, and there is a convenience function that allows us to, I'll go down here, which is check data. And essentially what we're doing is once that information is retrieved to us, we're looking for certain strings in our response. So for instance, temp_F is the Fahrenheit temperature. Once we have found that string, we extract the relevant temperature. Weather as well, once that's retrieved, we extract that weather information and relative humidity. So we're just searching through the response that comes back, and we are trying to extract the pertinent information that we need to display the weather. There are other ways that we could do this. There's a JSON library, that a third-party library that can parse JSON that's included. You can find for Arduino, I should say. This could be used to actually ingest that entire JSON string, and there's indexing on it. However, the memory footprint of the UNO is very small, so you might run into issues. I did run into some issues trying to use that library. This was just another way that I was able to get around that. So just ingesting the information and parsing it on the fly. It's not the most programmatically efficient, but from a memory perspective, I was able to overcome any memory issues. When we get our weather, the next thing we do is actually display it. So here is the display weather function that we call towards the end of our loop function. Essentially, it prints out to the LCD weather. It would print out that weather information, and then it would clear the screen and go on to display the weather string and then the humidity. So there it is. Fairly straightforward, just a few modifications from our previous programs, but it all fits nicely together, and we have created an online weather station. In this project, you learned how an Arduino Wi-Fi Shield could be used in conjunction with an LCD to retrieve and display weather information from Weather Underground. It was a great project and really illustrates the power of Arduino and how we can build wireless electronics projects that connect to computer networks. We have a lot of good momentum going. Let's move on to our next project.